Hi, I'm Ms. Hearn. Let's get started. Let's look at another example where we identify the slope and y-intercept given the equation of each line. So remember, when you're asked to identify the slope and y-intercept, you need the line to be written in slope-intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept. In part A, our equation is already written in slope-intercept form. You see how the y matches up with the y, and the term with a coefficient times x matches up with the term with a coefficient times x, and then we have a constant term at the end. By the way, this is a b, not a 6. Sometimes people have trouble reading my handwriting. And so m is the number being multiplied by the x, the 2/3, the coefficient. And our b is -1. So our slope is 2/3. And our y-intercept, well, remember, y-intercepts are pairs of coordinates. The x-coordinate of the y-intercept is always 0, and the y value we see is -1. So for part B, we don't have it in slope-intercept form yet, so we need to solve for y. So I'm going to subtract 2x. The procedure is always the same. Oh, and by the way, that is a 6. So subtracting 2x from both sides, we get 3y equals -2x plus 6. And to get y completely by itself, we need to divide both sides by 3. Now, here's a common error to avoid. A lot of times when people divide both sides by 3, they end up dividing maybe just the 6 by 3 or just the x term by 3. We need to divide both. This is actually -2/3 x plus 6/3, and 6/3 is really 2. So now we have our y equals mx plus b form, our slope-intercept form, where the m matches up with -2/3 and the b matches up with a +2. So our slope is -2/3 and our y-intercept, which always has an x-coordinate of 0, is going to be the point 0,2. Now this third line is a special case. This actually turns out to be a horizontal line. Notice that the x term is actually missing, which is odd, right? But if you want to, you can imagine that this is the equation 0x plus 1/2, which would explain why the x term is missing. So in fact, when you have y equals a number, the m is 0. b in this case is 1/2. So our slope is 0 and our y-intercept is the point 0, 1/2. I want to talk about how when we have a line in slope-intercept form, we can not only find the slope and y-intercept, but use the slope and y-intercept to graph the line. So in this example, we're given the equation y equals 2/3 x minus 1, a linear equation. We've just learned that we can identify the slope and y-intercept. The slope in this case, m, would be the coefficient of x, which would be 2/3, and the y-intercept would have a y-coordinate of -1, so 0, -1. This turns out to be enough information to graph a line because we have a starting point, and then the slope, 2/3, tells us the angle of the line or the direction in which we have to travel to find a second point, and we know we only need 2 points to determine a line. So let's go ahead and draw a graph of this line. Okay, so we're going to start at the pair of coordinates 0, -1. Our y-intercept is always our starting point. Then we're going to use m to tell us where to go, thinking of 2/3 as our rise over run. So 2/3. Remember, when we're doing rise over run, the sign is important. So we could think of this as +2 over +3. So +2 is our rise, meaning we're going to go up 2 units. And then +3 is our run, which means we're going to go to the right 3 units. This is going to put us at the pair of coordinates 3, 1. Sometimes students have trouble looking at their graph and identifying the new pair of coordinates, especially if your coordinates happen to have fractions in them, which does happen from time to time. So here's another method that you can use to get those points. It's a little bit more plug and chug rather than looking at the graph and figuring it out. So you take your starting point, 0, -1, and remember the rise is the change in the y value, and the run is the change in the x value. So you're going to change the y by 2 units, so +2, and you're going to change the run by 3, so +3, and you add them directly to the coordinates. So that gives you 0 plus 3 is 3, and -1 plus 2 is 1. And there's your second point, 3, 1. Now here's an interesting little fact. There's actually always going to be 2 points that you could get by moving from the starting point, the y-intercept, to the next point using the slope, depending on how you interpret the slope. Here's what I mean. 2/3 positive could also be interpreted as -2 divided by -3. So if you think of that as your rise over your run, then that's telling you to go down 2 and to the left 3. So let's see what happens when we do that. Down 2 and to the left 3. Now, let's say you're not sure what those coordinates are, you're having trouble reading your graph. We can use the same little trick as before. Our starting point is 0, -1. The rise is the change in the y value, and the run is really the change in the x. So our y value is going to be changed by -2, and our x value is going to be changed by -3. So let's add these. 0 minus 3 is -3. -1 minus 2 is -3. So our new pair of coordinates is -3, -3. Notice that this point is collinear with the other two. It goes through the same straight line. Okay, let's repeat this procedure with the other equation, part B, y equals -2/3 x plus 2. Okay, so our slope is -2/3, the coefficient of the x, and our y-intercept is 0, 2. 0, 2 being our starting point. So there's 0, 2, and then we're going to interpret our slope 2 different ways to get 2 different points. And what I mean by that is to have a -2/3 is the same as having -2 divided by +3, or +2 divided by -3. Looking at it as a +2 divided by a -3, our rise, or our change in y, is going to be up 2 units. And then to the left 3. So that's going to place us at the pair of coordinates -3, 4. Okay, or we could have thought of this as going down 2 in the y direction and to the right 3 in the x direction. And we would be at the pair of coordinates 3, 0. These are all collinear. That's supposed to be a straight line. So there's the line y equals -2x plus 2. Now, before I have you graph some lines on your own, I just want to mention a couple of special cases. First of all, when the x variable is missing, this is like, for this example, y equals 1/2. We don't have an x term. All this really means is that all the y values on the line are equal to 1/2. So what I like to do is to just list some ordered pairs where y is always going to have the value 1/2, and then you can pick anything you want for x. X has no restrictions on it. For example, here I picked 0 and 1 for x. You'll notice that you end up with a horizontal line. By the way, a slope of 0, because as we discussed before, this is like saying 0x plus 1/2. On the other hand, if y is missing from the line, that means that the x is always constant. So in this case, for example, x is always -2. So I listed a couple of pairs of coordinates where the x value is -2. I listed -2, -1, and -2, 1. And when I plot those, I see that I actually get a vertical line. Slope is how much the line rises for each step forward. The slope is actually undefined because it rises infinitely without any steps forward. It's kind of like infinity over 0, which is just not defined. There's no way to divide infinity by 0. In fact, you can't divide anything by 0. In any case, whenever you see that one of the variables is missing, you know you either have a horizontal line or a vertical line. So just plot a couple of points and you'll know which one you have. So I would like you to pause the video and work these 2 examples from the day 2 worksheet number 3. Find the y-intercept and slope of this line, y equals -2x plus 5, and then use that information to graph it. And then find the y-intercept and slope of this line, y equals -3/2, and also graph this line. Number 4, find the y-intercept and slope of the line and then graph it. Y equals -2/5 x plus 1. Remember, when we're finding slope, we have 3 methods of finding slope, but it depends on what information we're given. In this case, we're given the equation. So we're not going to use y2 minus y1 over x2 minus x1, and we're not going to use rise over run. We're going to use the slope-intercept form of the line, y equals mx plus b. The y-intercept is going to be the b, which is going to be the point 0, 1, and the slope, m, is going to be the coefficient of x, which is -2/5. Notice I didn't write m equals negative 2/5 x. It's not the whole term, it's just the number in front of the x. We're going to use this information to graph the line, and remember the y-intercept is our starting point. So the starting point is the y-intercept 0, 1. The slope is negative 2/5, which I can interpret as negative 2 divided by positive 5. So the rise is down 2, the change in the y, and the change in the x is up 5. You can always subtract 2 from the y and add 5 to the x, and that puts us at 5, negative 1. Or you can go down 2 and to the right 5 and end up at 5, negative 1 that way. So here we have a graph of the line. Now you might have interpreted the slope as being up 2 and to the left 5, and you would have found a point over on the left side of the graph, but your line should look the same. Now let's graph this special case line, y equals negative 3/2. Now the instructions say to find the y-intercept and the slope, and you can do this by either graphing the line first and then interpreting, or you can remember that in the case of y equals, that when the x term is missing, you can think of it as 0x minus that 3/2. So that would tell you that the slope is 0 and that the y-intercept is the point 0, negative 3/2. Common error on this problem is to see the fraction. Mentally, we associate fractions with rise over run, so people want to say that the slope of this line is negative 3/2, but actually the slope is 0. Another way that you could find the slope and y-intercept is to actually do the graph first. And remember, whenever you have a variable missing, what this is telling you is whatever the variable is that's given, in this case the y, is constant. It's always equal to negative 3/2, but the x can be whatever you want. So you can just plot a couple of points where the y coordinate is negative 3/2. X can be whatever. So let's say x is either 0 or 1, or you can plot more points if you want to, but we need at least 2. Okay, so to plot these 2 points, we need to understand this negative 3/2. Remember, negative 3/2 means the same thing as negative 3 divided by 2. So if you get confused about this, go ahead and divide it out on your calculator. You're going to see this is negative 1.5. Or you could use the technique of writing the improper fraction as a mixed number. 2 goes into 3 one time with 1 left over, so that's negative 1.5, which is somewhere between negative 1 and negative 2. So we're going to go to 0 on the x and halfway between negative 1 and negative 2 on the y. So there's the point 0, negative 3/2. And then we're going to go to 1 on the x and negative 3/2 on the y. There's the point 1, negative 3/2. And we see that we get this horizontal line. Now sometimes people forget, what's the slope of a horizontal line? What you could do is just use the y2 minus y1, because when you have 2 points, you can use the formula for the slope between 2 points. So let's say this one is our x1, y1, and this one is our x2, y2. Plugging into the formula, y2 is negative 3/2 minus y1 is also negative 3/2 over x2 minus x1 would be 1 minus 0. So negative 3/2 plus 3/2 is 0 over 1. 0 divided by a number is 0. So we would say the slope is 0, and we see that our y-intercept is 0, negative 3/2 from the graph. This is something one of my students taught me. I think it's awesome. When you have 0 divided by a number, how is it different from a number divided by 0? A number divided by 0 spells no. You can't do it. This is undefined. Whereas 0 divided by a number spells on, as in right on. You can do it. And the answer is 0. I hope you found this video helpful. If you did, please remember to like it. That will help other students to find the video.